So there are people in here in the room now.
Looks like everyone's joining.
Cool. All right, so Jessie says we've got about 8 so far in the room. Hi, everyone. If you want to jump on, and are people unmuted? Are they able to chat if we want? They can. Right. So if anyone wants to introduce themselves or say hello just while we're waiting another couple of minutes to get started, feel free to say hi. Everyone's shy.
Hello, Emma.
Hello,
Looking forward to you. Hello from Australia, from Sydney, Australia. Thanks for your work. We look forward to your presentation.
Oh, thanks, Steve. Appreciate it.
Also, while no one else is speaking up, a big shout out to Jessie and the CVent team too. They've been great. The whole support team, the volunteers. It's been very well run session. Well done.
Yeah.
Oh, good. Thanks, Steve, for saying that. Yeah, it's, I mean, such a massive change from what we'd expected even a couple of months ago. Yeah, so for this all to get pulled together, yeah, you're right. This is a big thing.
We partnered with CVent for AP Expo 2021. So similar event here in Australia last year, which was great, and they were great to work with then as well. So well done.
Hey, Brian.
It's 1:15, so why don't we get started?
Hello, ladies. Hi, Kayla.
Hi. Long time no see.
Yeah, how are you?
Good. Well, good afternoon, everyone. Thank you so much for joining in. This is IC70, which is using pressure mapping and mobile shower commode chair assessments. So our presenters will take over. Please, everyone, keep yourself muted right now and put any questions you have into the chat, and we will monitor that, and the presenters will answer those at the end. So thank you so much, and take it away, Emma.
Thank you, Kayla. Well, hello, everyone. Welcome to this session. My name is Emma Friesen. I'm the Clinical Director at RAS Design Inc. And we also have Jessica Presperin Pedersen, who's on as well. She's a clinical educator with RAS, and together we're going to talk about pressure mapping. As Kayla said, we will answer questions at the end, just so we know that we get through all the material. So I'm actually going to turn off my video to do this so that it's not distracting for everyone. All right. So the plan for the next hour or so, we're going to start off with some definitions. So we're going to define mobile shower commode chairs, pressure, interface pressure mapping, look at the uses for IPM, some of the limitations, and then talk specifically about some challenges that we see in mobile shower commode chair seating. So to start off, I want to just go through this acronym that we're now using, and it will be through all the presentation, MSCC. So by mobile, we mean that the chair is on wheels, it's rolling, and it's designed to be moved with someone sitting in or on it. It's a shower chair, which means that it is designed to get wet in a showering or bathroom environment. But generally, these chairs are not designed to work in a heavily chlorinated environment, such as a pool or a sauna or a spa or a saltwater environment like the beach. It's a commode, meaning that it has some sort of function that allows its use for toileting. So generally they have an aperture, which is a hole in the seat, and then either a receptacle underneath or provision for the chair to roll over a toilet, so any waste can go straight into the toilet and the sewage systems. And finally, it's a chair, and that's to distinguish it from, for example, a shower trolley or some other device where the user might be in a lying position. Now, pressure is what we're talking about today, and pressure is a mathematical term, and it is the force that someone, and in this case, it's someone's body weight, is exerting over an area. And what we see in seating as a general rule is that as the seat surface area gets smaller, the pressures that we see on the remaining body surfaces get larger, because the body weight or the body mass stays the same, but the area is decreased. So that's our basic formula that we're going to be working with. Interface pressure mapping. Now, interface pressure mapping, or IPM, it's a method of measuring contact forces between two surfaces. So in this case, when we're talking about seating, we're looking at the weight-bearing surfaces of someone's body and the support surface that they are lying, sitting, or leaning on. So generally, we see IPM being used for mattresses, wheelchair cushions, obviously you'll see a lot of in this particular conference. We use them on patient plinths, examination tables, and surgical beds. So for example, in an operating theatre to see what pressure is being exerted. We've used them on comfort chairs. So they would be, your day chair or another chair that someone might sit in, a recliner, for example. And then mobile shower commode chair surfaces. And primarily we're talking about seats with MSCCs. Now, a pressure mapping system generally has two major components. Firstly, you have a mat or some array of sensors. So all of your measuring devices are within a mat. Then we have a computer or a tablet or something that has software that allows us to do a graphical display. So it's interpreting and then displaying the data that is gathered by the sensors. So the typical data we'll get out of an IPM system, we have a photo here or a screenshot rather on the right, which shows a visual representation, which is done with colors and also the numerical value of the pressure in each cell. So we get a known load on each sensor cell. And because it's in a mat, we know the location of the load relative to the mat. We can calculate then the area of contact, so the exact area that the body, in this case, the body is being in contact with. The system will calculate a center of force, and then we have the numerical and graphical displays of the pressure distribution, and we can look or find the maximum interface pressure that's being displayed in this particular scenario. So there's quite a bit of information that we can get from an IPM system. So in terms of some uses for pressure mapping, and I'm going to go through 4, and just a little hint, these are the questions, some of the questions that you have to answer later. So you might want to take note at this point. So 4 uses for IPM. The first is so that we can find or locate particular anatomical landmarks that we know are at risk of developing some sort of problem, so some sort of pressure-related injury. Now, in seating, this tends to be the ischial tuberosities and the greater trochanters if we're just talking about the buttock or the seat surface, though we may also look at the back support as well, in which case we're looking at generally the spinous processes. We can also use IPM to show areas of unusually high load. And this can be really helpful where someone is presenting with an area that is obviously a concern in terms of pressure, but their risk factors are otherwise not high. So we're needing to investigate what's going on here, why we're getting, or where we're getting some unusually high load in a seated surface. The third potential use for IPM is to directly compare different pressure reduction or pressure redistribution equipment. So we've seen, there's been other presentations, and certainly the Pittsburgh team have done a lot of work in educating us on how we can use standards to decide between different cushions, and pressure mapping gives us another method of gathering data that allows us to make those direct comparisons, and it helps us with our selection. We can also then use it in terms of our clinical justification for particular pieces of equipment over others. And finally, a common use for IPM is for education. So that's education for the occupants or the users of our mobile shower commode chairs or our seats or whatever the equipment is. It can also be very useful for attendants and carers. We find it in this setting, for example, it's a very good educational tool for clinicians to start understanding what happens with pressure and how it changes as people move. And there are maybe others who need to understand and be in a position to manage someone's posture and pressure. So there's multiple ways that we can use pressure mapping. And I have to say that in my role, the education component is a really, really big one and a really powerful one. You really do get a good idea of what's happening with IPM. But what I want to do now is talk through some of the limitations, because yes, IPM systems are great and we can get a lot of information out of them, but we also have to understand the limitations so that we know when our clinical reasoning needs to really come in and help us understand. So the first limitation is around uncertainty, because the interesting anomaly here is that the act of measuring changes what we are measuring. So in this case, we are trying to understand what is happening between the person's body and the support surface, so the cushion or the chair or whatever that they are sitting on. But what we're now doing is putting a sensor mat or an array of sensors in between those two surfaces. So that actually does potentially change what gets measured and how it's getting measured. So it can change the readings, meaning that the pressure readings that are showing on the mat may not be representative of what's really going on. The mat itself can change the compliance of materials. So when we're talking about something like envelopment and how the surface is conforming to the body, the mat itself can change that on a seating surface. So we have issues potentially with the flexibility of the mat compared to the flexibility of the body surface and the seating surface. And we also potentially have a phenomenon called hammocking, which we'll talk about in one of the later slides. So here's an example. This actually wasn't taken with a mobile shower commode chair seat, but was taken with a custom-made cushion that had a very, very deep aperture, essentially to support the ITs or to allow the ITs to float. And what we see happening here is that as the mat is trying to push into that large, deep hole, it's actually creasing on the sides. So some of the red areas that are visible that sort of look like rays going out from the corners of the mat, corners of the aperture, are actually creases in the mat. So when you first look at that, you might think, oh my goodness, we've got some red areas of higher pressure, they're in red, but what's actually going on is that the mat has creased, and that's what we're actually reading. We can also get a phenomenon where we get a false reading where the mat has to go around an edge. Now, this is something that does happen on mobile shower commode chair seats, depending on how the radius of the edge of the aperture is shaped and how firm it is. So what's happening here is that the mat is getting pulled in two directions. It's getting pulled down and across. And so we're getting a tension effect on that corner, and that is producing a false reading. So again, it might show up as a very red spot on our pressure, our visual display, but what's actually happening is the mat is stretching. We can also get unexpected load lines just because the mat's creasing. So we saw one earlier that was occurring when the mat was trying to conform to a very large hole. But what we often see is as someone is sitting, when we put the mat down, we get someone to sit back down on the mat, we can sometimes get creases. And those creases will show up as lines of high load. So if you're seeing those kind of really distinct lines, there's a good chance that you need to check the mat and make sure that the mat is flat and not creased, and then start looking at what's going on with the pressures. All right, so and the second area of limitation is to understand what exactly it is we are measuring. Now, when it comes to measuring forces, our forces is divided into two components: a normal force, which acts tangentially to the support surface, and then a shearing force, which acts in the same direction. So our pressure mapping systems are measuring normal force, so just the force that's acting directly at 90 degrees to the support surface or to the mat. And what this means is that when the mat is conforming down over a curved surface, for example, we're seeing envelopment here of a cushion that's conforming to the user's buttocks, the actual force of gravity is pulling straight down. But when we break that force up into its normal force and its shear force components, we're actually getting different readings. So it's not always quite clear exactly what might be going on because of how this mat is measuring, or the particular normal force that it's measuring. What we do see sometimes is that if we have a very steep gradient of pressure, it's quite possible we're dealing with shearing forces, that shearing forces are going to be present, but the mat isn't going to actually tell us that. This is something that we're going to do from clinical reasoning to understand what's going on. So we're getting this visual display that's showing very quick changes from low pressure to high pressure, so in a very short little area on someone's body, and that can be a flag for us that we need to investigate whether shearing is going on. And another area of uncertainty comes not so much from the mat itself, but from the tissues that we are measuring or that we're loading in seating. So the mat doesn't know what skin is being supported, but what we know is that skin can perform differently. So uninjured skin actually performs quite differently to skin with scar tissue. So scar tissue has different stiffness, it can have different resistance to failure and therefore damage. It can have different or altered material directionality, so that's how it moves under load. So even though the pressure mapping system will show that the skin or that area might be subject to quite low pressure, the fact may be that that skin itself is damaged and therefore not able to tolerate the same loads, the same pressures as uninjured skin. So that's something where we as clinicians need to, and as technicians need to understand what's going on with the person's body, what's going on with the particular areas of skin, and then make that clinical reasoning or go through that clinical reasoning process of understanding whether that tissue will be able to tolerate that load that's being placed on it in seating. All right, so in the next bit of the presentation, what I want to do is talk about the challenges we see in mobile shower commode chair seating. And I've picked out 5, there are quite a few. I know many people here are quite familiar with wheelchairs and have done quite a lot of work in scripting and assessing and using and understanding wheelchairs. So in this part, what I'm looking at doing is making some comparisons so I can show you how mobile shower commode chairs are different, and that way you can draw on your knowledge of wheelchair seating and see how it can apply to mobile shower commode chairs. So here are 5 challenges that we see for optimizing posture and pressure in mobile shower commode chairs. And I won't read them out because I've got them on slides as we go. So the first issue that we have is that our mobile shower commode frames need to be wide enough and high enough to roll back over a toilet, because that's generally how we're going to be using our mobile shower commode chairs. And our goal is to have the chair roll back far enough over the toilet so the aperture is fully positioned over the toilet bowl. And that way the waste can go straight into the toilet and out through the sewage system. So there's a whole lot of things that can create challenges for making sure that the frame is wide enough and high enough to get back over the toilet. One of the issues we then see in seating is that you'll know on many mobile shower commode chairs, when the base is wide enough to go back over the toilet, the manufacturers keep the back frame the same width. So you need a chair generally that's at least 18 inches wide to fit over most toilets. And if you've got then the same back frame, that means your user is sitting in a chair that is 18 inches wide at the back. Now, we know that many of our users are not that wide. They don't need a back frame that wide. And that actually creates some challenges in terms of their posture and positioning, because it means, and we have a photo here of a gentleman on the left, he's sitting in a chair with an 18-inch wide base and an 18-inch wide back, and you can actually see part of the back frame on either side of his torso. So this chair is too wide for him. So this means he's not getting much support in terms of lateral stability. So that's going to affect his balance and his functionality in the chair. It also means that as he reaches out to grab the hand rims, because he's sitting here in a self-propelling version of a mobile shower commode chair, he's needing to reach out over the arm supports to get to the wheels. And the arm supports attached to the back. So with an 18-inch wide back, they're quite wide. So in the RAS range, we've developed the capability to do a different size back frame to the base frame. So our back frames are bolted onto our base frames, and that means we can create different sized back frames. So in our photo on the right, our gentleman is now sitting in the same base frame, 18 inches wide, but the back frame is now 14 inches. So he has a lot more postural torso support, because the tension adjustable upholstery can allow it to wrap around his torso a bit more. And the armrests are now narrower or closer to his body, which means he doesn't have to reach around as far to get to the hand rims. So this is going to be a more functional, a more efficient propulsion setup for him. All right, the next issue we have is that the seat frame on an MSCC generally has to be horizontal, and this can impact someone's stability as well. So we very much see this in users who have manual wheelchairs with a very aggressive seat to back angle or rake or dump in their chair. So they're really tightly in a manual chair. So the chair's very small, it's very compact. They get a lot of support and stability in that chair. But we can't replicate that in a mobile shower commode chair because we need the frame to be able to go back over the toilet. So that means that we have to rely on different postural supports and perhaps add postural supports to the mobile shower commode chair, even though they don't use it in their manual chair. We also have the situation where the center of mass will generally be higher in a mobile shower commode chair, and this affects, for some people, this can have quite an effect on stability as well. And so what it means is that we have to look at other options to compensate. So it could be that a person needs tilt-in space in their MSCC, whereas they don't need it in their daily manual or power chair, but that's because we can't replicate that same setup. All right, the second challenge that we have is that the seats on MSCCs have apertures. So that means they have a great big hole in the middle. Now, right at the beginning, I said that pressure is a function of force divided by area. And as the area gets smaller, the pressure gets bigger. So in a mobile shower commode chair seat, this aperture is taking away area. So it means the pressure on the remaining body surfaces is going to be higher. And for our chairs, it means that our pelvic positioning becomes very, very crucial. What we need to do is make sure that the greater trochanters, the subgreater trochanters, are loaded. And generally, we want to see the ischial tuberosities free and floating inside the mobile shower commode chair seat, so within the aperture. So it does mean we have a fairly narrow range to play with in terms of getting the aperture the right size, because if we go too wide on the aperture, the only part of the greater trochanters are supported and actually start rolling or forcing the person down into the seat. So it's really important that we get this right. The third challenge that we have is that our MSCCs are designed to get wet. So in everyday use, they're going to be exposed to water, to steam, and to heat, just in a bathroom environment. They're going to be exposed to chemicals, so just our regular bathroom chemicals, soaps, detergents, shampoos, cleaning products, all of those kind of things. Hopefully, they're also going to be exposed to hygiene and infection control products. And in some, for example, in institutional settings, in hospital settings, these frames or these MSCCs are going to be exposed to, for example, wheelchair washers or some high temperature, high pressure cleaning environment as well. So they are going to get wet. And this has an impact on the selection of materials that we can use to manufacture an MSCC. So firstly, it means that our frames and all the components within the frame need to be waterproof, and they need to be rust and corrosion resistant. It also means that the materials that we use for seating are limited, because what we know is that foams deteriorate when exposed to liquid. And it means that any foam surface needs to have some sort of protection, a water-resistant protection to protect the foam. So it could be a plastic, it could be a waterproof stretch material. But what this means for seating, and this is particularly relevant if your experience is in wheelchair seating, it means that we can't use the same fabrics. So all of those wonderful fabrics we have in wheelchair seat cushions that allow us to play with microclimates and promote air circulation, basically we can't use any of those in mobile shower commode chair seating. And that presents a real problem or a real challenge if someone is needing to manage pressure and skin integrity. And now this is what we talk about, that we need different approaches. So as I said, we can't use the same materials that we use in wheelchair seating because we have this wet and soapy or wet and chemically involved environment. And it means that the seating materials we do have, the waterproof seating materials, don't tend to offer the same potential for immersion and envelopment that we get in our wheelchair cushions. We have an additional challenge here in that the user, when they're in a mobile shower commode chair, generally they don't have clothes on. Generally they're getting wet, so the skin becomes exposed, it's wet, and it's very vulnerable, and it can be then at very high risk for tearing, for friction, and for shearing as they're using the chair. So that's a real challenge, and particularly in some of our neurological, with some of our clients with neurological conditions. So I said before that we have to use different strategies for managing posture and pressure and skin integrity. So in a mobile shower commode chair seat, we're usually relying less on inversion and less on envelopment and far more on offloading. So this is an example of one of our RAS molded foam seats. And we've done a lot of work to contour this seat to maximize the amount of area or the amount of pressure that's taken, that the body surface is taken under. So our contouring, it stabilizes the pelvis and makes sure that the sub greater trochanters are loaded and that we are offloading the ischial tuberosities. We generally have a relief channel at the back to make sure the coccyx and the sacrum aren't going to be exposed to pressure. And then we have a raised section at the front to make sure that the thighs, the proximal and distal thighs, are going to be well loaded. And it also means that we're helping to keep that pelvis in the position in the aperture while someone's using and being functional on the chair. And it also means that we have to be really careful and to optimize the seating, the setup of the whole chair. So if you've got options for contouring the back support, for example, using tension adjustment, that can help take some of the pressure. You want to make sure the arm supports are at the right height, and also look at the position of the foot supports. So just to give you some examples, this is a pressure image that we took of a gentleman in one of the RAS seats where the arm supports are set up at a good height for him, but the foot supports are not. In the next picture, we see that the arm supports aren't set up well for him, but the foot supports are. So you can see that there is a difference in the way the pressure is on the chair or on his body, and we're getting more support under his thighs when the foot support is set up well. And in our final picture here, we have both his arm supports and his foot supports set up appropriately, and we see quite a significant drop in the highest pressure that his body is experiencing. So this is just an example in terms of education of how a couple of different pressure mapping visual images can show you what's going on, and just how different those different seating setups are, and the different pressure that you get. At RAS, we have something called the IPAS, the Ischial Pelvic Alignment System. And this allows us to move the seat and move the aperture so it matches where the user's pelvis is. So if you have a fixed seat on a mobile shower commode chair, it means the pelvis is forced into a particular position, and that position may not be comfortable, it may not be functional, it may put the person at risk in terms of pressure and well, you know, the bony prominences that might be exposed. So the IPAS system allows us to adjust the position of the aperture to match what the user needs and the pelvic position that the user needs to adopt. So that's another way we can manage pressure. On this slide, the QR code will take you to a video that we've just launched that shows the IPAS system. And here's two images that show the IPAS. So this is one with the seat in the rearward most position. The second image is with the seat in the most forward position, and you can see that the way the pressure is distributed is quite different. Another change or difference we see is the difference between seats that have no side access and seats that do have a full cutout on the side. Now, this is particularly relevant in spinal cord injury, where a user might be wanting to do their own bowel care, their own digital stimulation, manual evacuation of their bowel. So we might look to do a full cutout on one side. And so if we have a chair that's got no opening on the side, when someone leans over, so in this case, our gentleman is leaning to the right, we start getting very high pressure readings on that right side as he's leaning over. And even in a seat that is better contoured and better cushioned, if someone is leaning over, we're still going to see quite high pressures, usually on the greater trochanters, on that right side. But if we then have a seat that has an opening, a full cutout on one side, it means the user doesn't have to reach around as far, and we get much lower pressures, and we actually don't or get very minimal pressures on the greater trochanter on that right side. So that's quite a difference that you see just having that opening. And again, we might need to look at tilt in space, because we may need to offload pressure from the seat and onto the person's back. So in terms of your clinical justification, your rationale for tilt in space, firstly, in terms of skin integrity and pressure management, is that it facilitates offloading. So even more offloading onto the back. It can also help with functioning, because it's going to help improve someone's stability. They're going to be safer because they're being held back in the chair by gravity. It can assist with transfers, particularly with hoist transfers. And it can also assist with under-seat access. So if a caregiver is needing to access the perianal area for hygiene purposes, the tilt in space can make that access easier. We could also improve someone's posture with tilt in space, and so it's assisting positioning. And finally, we have someone's comfort. It can be very comfortable to wheel into a shower, to go back into some tilt and just sit under some hot water for a while. And if someone wants to do that, the tilt makes it safe and possible for them to enjoy that experience. We can also, at RAS, we can also offer a tilt and recline features. And this is a way to really just redistribute pressure away from the buttocks. This is a design that is really good if people need more access in terms of catheterization and also bathing. A chair with tilt and recline is starting to put the user in a position that's more like a shower trolley, but it's actually a much more functional position. So if you do have someone who's perhaps needing to be in that kind of supine position for bathing and toileting and showering, a chair with tilt in space and recline can be a really good option there. All right, the final challenge that we see in MSC seating is that we generally have far fewer options and accessories when we compare them to wheelchairs. So in wheelchairs, we know there is a huge range of cushions and back supports and postural supports and positioning options and components made by a whole lot of different manufacturers that can go on different chairs. And that's not the case in mobile shower commode chairs. Firstly, there's just generally a much smaller market. There's far fewer manufacturers. And generally, and Raz does this as well, any options and accessories that we manufacture only for our chairs. They are only designed to be used on Raz frames. So it means that you're, as a clinician, if you're trying to select the best back support and cushion and whatever other options you need, you really are limited and may have to stick with just one manufacturer's chair because you get whatever options and accessories that you need. And this becomes a real challenge if you've got a client or a user whose needs are going to change, where you know their needs are going to change over time and over the lifespan of the mobile shower commode chair. So in your assessments at the beginning, something you can start looking at is, firstly, what options and accessories are only available when I order this chair initially. So it could be that you can only get tilt, you can only get recline, you can only get certain features like that at the time you order the initial frame. That could be true of postural supports as well. If someone is wanting to use a smart toilet or a bidet, and I understand that's starting to happen in North America, it's something that's very, very big in the UK and in other parts of the world. And in some bidet designs, you do actually need a wider frame than sort of the 18-inch standard that we would go for. So if your client is likely to want to try a smart toilet or bidet, it may mean that you have to purchase a wider frame upfront. The second area you want to consider is, what can we change on the chair down the track? So after a few years, for example, our users' needs have changed. What can we upgrade? What can we change or adjust on the frame to make this chair still functional, still usable, still individualized for our particular user? So that could be in terms of the adjustments that are inherently in the frame. You know, are there adjustments we can make to the back support, to the seat to floor height, to the foot supports, to the arm support height, to the headrest height? Those kind of adjustments that come just as standard with the chair. We might also look at the options and accessories that are available that we can swap in and out. Look at whether it's possible to replace components on the chair. So is it, for example, possible to replace the whole back frame with a different size, with a different height? And then are there any options for modifying or retrofitting? So could we make modifications to the frame if we needed to? And in the Raz chairs, in our stainless steel range, it is possible to modify a frame if we needed to do that. In some other frames, like aluminum frames, that's often not possible. So just a summary of the kind of adjustments that you might want to consider or might want to look for when you're doing an assessment and trying and helping your client to select a chair. Is things like the back frame and the width and the height, the seat to back angle, where there's any adjustment in there, the back support. So in this case, we have a tension adjustable back support that allows us to do some mild contouring. Can we adjust the seat to floor height, which can be really useful if, you know, because there's always a challenge in getting the right height to go over a toilet, but also the right height for transfers. And it may be that as someone's needs change, their transfers change, and we have to adjust the seat to floor height. The arm supports, both the height and the pads that are on there, we might need to change. The seat position we've talked about in terms of the iPass or the capacity to move the aperture. We might want to change the actual seat itself. So we may, you know, if someone's risk factors for pressure injuries change, it may mean we have to go from a sort of a less immersive seat into one that is recommended for pressure management. So it could be a visco foam seat, for example. And then we look at the foot supports and the different heights, as well as the different styles that are possible on the chair over time. All right, so just a quick summary of what we've been talking about for the last little while. Basically, we've got 5 strategies that are coming out of this to optimize pressure and posture. The first is to consider the height and the width of the MSCC frame and how that's going to impact posture and pressure. So we talked about the case where the back frame and the base frame are the same width, and for some users that's going to mean the back frame is too wide. So is it possible to get some sort of narrower frame at the back that still allows us to fit over the toilet? Or do we have to look at postural supports, tilt-in space, or some other options? The second thing to understand is that the environments of use are going to be wet, soapy, slippery, unsafe, and that's going to impact our choices for materials, both for the mobile shower commode chair frame, but also the seating surfaces. We also want to check that the seat and aperture designs are okay and are going to work for our clients. We want them to be functional as they're sitting in their seats. And we also want to make sure that those apertures are coming back over the toilet if we intend to use the chair over a toilet. So we want to make sure that the seat design works and that the positioning over the toilet is what we're looking for. We talked about using offloading as our primary primary way of managing pressure, whereas in wheelchair cushions we do a lot more in terms of immersion and envelopment. So we are using offloading here because we need to overcome those limitations in the materials, because our materials have to be waterproof. So we are looking a lot more at offloading and a lot more at contouring of the seats to get that pressure distribution for the user on the seated surface. And finally, we want to talk or consider the options and accessories that are going to be available at the time that we initially purchase the mobile shower commode chair, but also with a view to the future in terms of what could be adjusted, what could be retrofitted, or what could be modified later. So that's a good summary of what we've now talked about. And I'd like to open up the floor to questions. What questions do you have? All right, I can see a question here. Have you ever considered embedding sensors into the cushion to get real-time feedback? At RAS, no, we have not. That is something that I think is worth talking about with some of the experts in pressure mapping research. I think one of the challenges we have in doing that in mobile shower commode chairs is that the sensors would probably need to sit under some sort of waterproof coating or waterproof fabric, so a vinyl or whatever, because the sensors, if they're going to be sitting on top of the cover, we might as well just use the sensor mat. So the fact that they're going to be underneath the cover is already going to change potentially the readings that we get. So it's sort of a bit of a challenge there, and I think that's one where I'd like some of the experts who do research on pressure mapping and cushion design could help us out with that, to see how we could get sensors in place, but in a way that they're measuring accurately.
Hi, I really loved your talk. I love RAS chairs. I feel like they're the best on the market right now. I know you talked about how, because of the waterproof problem, you can't really have like a squishier pad, but the biggest complaint I hear about the RAS chairs is how uncomfortable it is. They can't sit in it for that long. I have a client who he just takes out all his upholstery and then just showers in his regular ultralight chair because it's too uncomfortable. The RAS is too uncomfortable. Have you guys thought of using like air combination of using air and the material you use now, because I work in I was in a rafting company, so a lot of like waterproof, watertight air rafts. There's also a lot of like PVC coated that are waterproof for if you're on like a overnight trip and you have to sleep on like waterproof mats, but they're really comfortable. They're like a mix of foam, and they have like a valve that's like airtight and watertight, but it's really comfortable. Have you guys thought of using air as a cushion?
It certainly is something that is considered. I mean, in a commercial sense, it's probably not viable for us to do that, you know, as a commercial offering, and that's the honest truth about why we haven't really looked into it. Individual users that, you know, we do see people who get a RoHo overlay or a Vicair overlay or some sort of other overlay that's starting to bring air or bring more contouring into the equation. We've done other things. We've actually, on our molded foam seats, we've worked really closely with the manufacturer to get a unique recipe essentially that makes a really soft closed cell foam for our molded foam seats. So that's one thing, but it could be that your user is just, you know, one of those extreme cases where it's just still not going to work. So in that case, maybe putting another manufacturer's overlay may be the solution, rather than something we do commercially.
That's a good idea.
Yeah. Because I know Vicair or Vicair, depending on where you are in the world, they have a Commode seat overlay. RoHo do something, or, you know, can create something with a hole, and then you're just looking at how you attach it to the seat so that it's still stable and functional for the user, but then bringing in that comfort and function factors for their particular use. I'm just scrolling back up. Okay, we don't have any other questions, but look, if anyone has questions or wants to chat about something, please do jump in, because we're here and Jessica's here as well. If you want to. Gosh, we've got a couple of Australians on the call. Oh, this is so nice. And someone's just commented that the aging SCI population is growing when we may need to consider air cushions. Look, that's a really good point, and I take that on board. I think, as I said, I will probably go and talk to manufacturers that are already making those kind of products and seeing if we can collaborate with them rather than trying to come up with something new on our own, at least initially. Yeah, just to see what's possible there. Do you have anything to add to that, Jess?
No, I'm just, I think the concern with going with a RoHo cushion is increasing the cost.
Yeah.
So that's the issue is, you know, they're paying for the shower chair and now they're going to have to pay for the RoHo overlay. So I agree with you that initially it'll be good to at least offer that opportunity. And then if we can't keep the cost down by using two different manufacturers and two different products, have the possibility of incorporating some type of manufactured cushion that relieves pressure a different way.
Yep, and Steve's just commented that Supracore have a seat, a potential for a seat as well. There's probably a few other manufacturers of gels and overlays that we could look at. So yeah, and actually that's a good point, and something I'll take to the next Reha Care, assuming it goes ahead in September.
Yeah.
That's the kind of venue where we'll see some of those offerings. So I'll make a point of going around to see what is possible. Someone has just written, sorry, at Craig Hospital Skin Clinic, we would use your future air cushions. Thank you, no pressure. A draining aluminum seat pan to put a Supracore cushion on it, just a thought. Okay, that's yeah, in which case you may not need the type of frame. You can use a different type of frame if you're then only using a base.
Well, or they might use the standard seat and then put the Supracore on it, because a lot of people do use Supracore for bathing. So
Yeah,
that
yeah.
would help.
Okay.
They need the code. We have to get that code out there.
Yeah, right. Okay.
Oh,
Yes.
there it is.
Yeah, I just put it in the chat, but I will also read it out loud for everyone. So CEU code for this session is 7PRYC0. So, I mean, I think we still have some time. So if people have more questions, please stay on and keep asking it. But those who are finished up are welcome to go complete your survey.
Excellent.
Thank you so much.
I'll just point out the QR code I put on the screen here is see you, Steve, thanks, is just to the RAS website. So it's nothing too fancy, but it takes you to the RAS website. On our website, we now have all of our products. Obviously, we have a galleries tab that has a whole lot of different pictures of all our options and accessories, as well as a custom gallery. So you can see what custom options are possible, and many more are possible. And under our resources tab, we now have a RAS family brochure, which has all of our chairs. We have a RAS Barry brochure, which is our bariatric range. We've now separated that out and now market it as a separate range. And we also have an options and accessories brochure. And RAS has produced a evaluation and justification form. And that's one that Jess has worked very hard on, along with Chris and the team. And that one will take you through each of the options and accessories in each of the different parts of the order form and explain what those options and accessories are, what the clinical rationale for choosing them is. So it's on one hand, it's very good for writing your letter of medical necessity, but I've found it's actually also a very, very good education tool, because it means you're stepping through and getting to understand what's going on with the chair. So I actually have started using it in doing clinical education around the world. So yeah, hop onto the website and use that.
Bye, thank you.
All right. Well, don't be shy. If anyone else wants to ask a question, we're here and we've got plenty of time. It's nice we finished early, not we didn't run over. I would rather finish early.
Sure. Let's see anyone else popping in. Jesse, do you want to stop the recording since it seems like we kind of finished up with our questions?